current I flows in a conductor placed perpendicular to the plane of the paper, indicate the direction of magnetic field due to a small element vector dl at a point P situated at distance vector r from the element as shown in figure. So we have this diagram or figure, okay, and we have current I, okay, flowing in positive z direction, okay, and we find from the question, okay, current I flows in a conductor placed perpendicular to the plane of the paper. So let the plane of paper, okay, with this, okay, so this is the plane of paper in xy plane, okay. So we have conductor, okay, you can understand in this way. We have conductor carrying current I, and the direction of current is along positive z-axis. So what we find, current I is perpendicular to the plane of the paper, because current I is flowing along positive z-axis, whereas the plane of paper is in xy plane. And we are asked to indicate, okay, the direction of magnetic field due to a small element. So we can see in the figure, okay, we have a small element, clear, having length dl in magnitude. So this is small element. So if I write in this way, okay, I times dl vector, then this represent current element, okay. So we have this, and this is origin O, okay. Now we are asked to indicate the direction of magnetic field due to a small element, okay, at point P. So we have point P situated at distance vector r from the element. So this distance, okay, this distance is vector r. So we have this. Now, in order to indicate the direction of magnetic field due to this small current element or small element of a conductor carrying current I, we use Biot and Savart law. So I'm writing over here, okay. We use Biot Savart law, okay, to indicate the direction of magnetic field due to small element, okay, dl vector, or current element I dl, okay. So I'm writing in this way in a vector form, clear. So we use Biot and Savart law to indicate the direction of magnetic field due to small current element, okay, dl, or current element I dl at point P. So we have this, and we know, okay, from Biot and Savart law, okay, we have this. So I'm writing over here dB, this is small magnetic field, okay, at point P due to small element. So this equals mu naught by 4 pi So this is current element, okay? And we have cross product of vector r vector, that is position vector. So we can see in this figure, okay, OP equals r vector, okay? So we have this divided by r cube. So we have this. So this expression gives, okay, this gives magnetic field at point P, okay, due to current element ideal. So we have this. Now to find the direction, okay, what we do, we can see the direction of dB vector is given by the cross product of current element with position vector, okay, r. So we can see, okay, or we can write in this way, we have this, okay, we can see we have this dl vector, okay, this is along z axis. So we can write in this way, okay, dl magnitude of this, okay, times k cap, okay. So this is unit vector. So we know unit vector along x is I cap, along y is z cap, and along z is k cap. So we have this, clear? And we have r vector. So what we find in this case, okay, it is along positive y-axis. So we can write in this way, magnitude of r times z cap. So we are going to put this relation, okay, or we are going to put the value of dl vector and r vector in this equation. So let's call it equation 1 and this is equation 2, okay. So collectively these two are equation 2, okay. So what we do, from 1 and 2, okay, we have dB vector equals mu naught by 4 pi, and we can write in this way I. So we have dl k cap, okay, cross, and r vector is r j cap divided by r cube. So we have this, okay. Now we can write in this way also, this is mu naught by 4 pi I dl r, okay, and we have k cap cross z cap divided by r cube. So we have this. Now we know, okay, this, okay, we know this relation I cap cross j cap is k cap, j cap cross k cap equals I cap, okay, and k cap cross I cap is z cap. So we have, you can see we have k cap cross j cap. So this, okay, I'm writing over here k cap, okay. So we have k cap cross z cap equals minus I cap. So we are going to put this, okay, over here. Therefore, we can write dB vector equals mu naught by 4 pi I, and we can see, okay, this cancels out, okay. So we have IDL divided by R square, and this products, okay, cross product gives, okay, minus I cap. So we can write minus I cap. So what we find, okay, we find this, or we can simply write in this way, minus mu naught by 4 pi IDL by R square I cap. So we have this, okay, we have this relation. So what we find, magnetic field due to small element at point P, okay, this is along negative x-axis. So I'm writing in this way, okay, or we can write directed along negative x-axis. So we find this, okay, since positive x, this is perpendicular to the plane of the board, okay, and is directed outward. We can see it is perpendicular to the plane of the board, directed inward, and we have this, okay, we have this. This is negative x-axis. So what we find is that magnetic field at point P, okay, magnetic field at point P is along, okay, this is along or directed. So I'm writing over here, along negative x-axis. So we have this.